Hello and welcome to all of you from the RBS Research Research Academy. In this video, I'm going to train you how you can check the linearity of your data in SPSS. Dear friends, checking the linearity of data is very much important assumption among the different assumptions. Whenever you want to run the multiple regression, so now this multiple regression requires certain assumptions like the first assumption is the data should be continuous linear relationship, no significant outlier. And another one is the independence of observations, homozygosity, and the residual error. So these are the various assumptions which must be made before applying the multiple regression in SPSS. Although all are important, but as the literature suggests, that the linearity is the much more important than all other ones. Even though if the all assumptions have been properly made by your data, but if the data is not linear, then the results of your multiple regulation would be inaccurate, would be invalid. So that's why you know how much it's very important. So that's why I thought why I should not train you how to check the linearity of your data in this case. Now, in this, you know that I'm working on the skilling data. In this one is another video. So far, my different videos are available on the missing data, outlier, normality, and this is another video where I'm going to check the linearity of your data. And then now the linear regression needs the relationship should be uh, linear between the independent and the dependent. That's very important, as I already told you. This means that you should check the scatter plot of your score, and through the scatter plots, we can check out that either our data is linear or not linear. Now, this is the one image through which you can understand the linearity. Now, for example, these red line, they dots, these are the data points. And this line shows that all these regression line. So now the data points are above or below the data points are available. Now is the one variable increasing, another is also increasing. So this means that data is linear. So now the two variables in your data, they are linear. These are most important assumptions, as I already told you, because of it's not true. Even though all assumptions are made, your model is invalid. Now, the reference is from the field, very interesting book of the Andy Field. The name of this book is the Discovering Statistics Using SPSS. A wonderful book. I personally suggest you please go through and through this one, and you can have a wonderful idea of that one. Now, in this one, how we can check that we can check to the first we go okay. Now, if you want to go to the apply the regression, you need to that have a like a linear data. So linearity can be also checked through the correlation. Now, these are the four different state of your data. Now, if the data is like in this way, then all are increasing or all are increasing. If this is the shape of your data roughly, not exactly, but roughly, if this is the shape of your data, or if it is the shape of your data, then means that these are the positive linear association and there is a negative linear association, but both are the linear. Now, the association or relation among the between the two dependent variables may be negative, may be positive. That's not a problem, but important problem is that the relation should be linear. And then now it's another linear, it's a non-linear relationship. And this is also another non-linear relationship. If this is the shape of your data, it means your data is non-linear. Now, and then, for example, we are going to follow our example to understand the linearity of the data, how much is important. Example, for example, there is a restaurant manager who wants to check the linear relationship between the quality of physical environment and the food quality, service, customer service, violence, their image, and the restaurant image. So these are the different, like the individual variables are there are the aspect of the quality of physical environment. And then here the dependent variable is the quality of physical environment and the independent variable are all these. So now in the practical session, so we will follow this example. Now, checking the linearity through the scatter plot, we will check the linearity through the scatter plot. Now, this is the shape of the scatter plot. And the data which I will use, the data checking the linearity multiplication. The same data is available. The link is given at the like at the below of this like the video. You can open this link and you can download the same data for the practical purpose. And in this one, we say to prepare this data, I have required these type of, usually I require these three books. Whatever I'm like presenting here, I always refer these three books. And now in this one of the reference I have given from the ND field. So I personally suggest you please go through this one. And in my first video, I introduced about these three, I think these three books from the level of easiness level of contact. This is a much more easy for the beginners. These books are wonderful, and this is an intermediate, like somewhat easy, somewhat difficult, and this is somewhat advanced level book. And after finishing these two one, you can directly come on this one. In the practical session, uh, this is the data set where the QPE, quality of physical environment, is our dependent variable. Food quality, service quality, behavioral intention, customer service, balance, and these are our independent variable. And almost there are more than 270, 250 observations. So that means it's a quite big data set. Let's start how to check its linearity among the different variables. So first of all, to check the linearity, we should go into the analyze and check either there is a correlation between the two variable or not. So how to check? Go into correlation and click the bivariate, and then what you do is you should select from the QPE to restaurant image all these one except the ID. Then shift these one into the variable and do not do anything. Just okay. Okay. Now this is very important. Now, if you uncheck it, then those where the significant relationship is there, this will not be like the indication will not be given there. So it is very important that you should flag the significant correlation. Why? Whenever there is significant correlation between the two variables. So now, if you check it, then a static will appear on the significance. So it's important that you should keep it checked and then press OK. After pressing OK, now these are the results of the correlation in that one. First one is quality of physical environment. This is our dependent variable. Although in the correlation there is no independent or dependent, all are the variable. There is no discrimination. But for our own understanding, we say that just for we say that the quality of physical environment is our dependent and rest are our independent variable. Then if we check the relationship between the QP and the quality food quality is a wonderful. It's 0.38. And if you check the service quality in QP, it's a 0.481. It's quite a good. Your relationship is between the two variables. But if you see the rest of the your variables, then you can also check that these are also have a very good relation with each other. So now all are there within the range. Except this 1.29. Although that means if we round off it, it will become the 3. So now the normal the level of the correlation should be from the zero point 0.3 to zero point 0.7, or someone say zero point 0.8. If this is the relation between these, this range is there, this is a quite a good relationship between these between the two variables, because two variables are related with each other. If there is a less than zero point 0.3 or less than zero point 0.2 or like the 1.9, 1.8, like this one, it means that here you are going to compare, here you are going to create a relation between the apple and orange. So now both are not related with each other. So that's why relation should be there. So from this one, it's clear that all the variables are highly correlated with each other. They are not highly, but these are correlated with each other. Another important thing which I want to show here, that this is the static. You see the static, double statics are on all these one. These double asterisk basically shows that there is a significant relationship between the food quality and QPE, and all are there. Another, for example, there's a significant relationship between the QP and the balance. There's a significant relationship between the restaurant image and the QP. If the double static is there, it means there's a significant, and we can say there's a linear relationship between these two. One. Now, double static means like this one. The correlation is significant at the level of 0.01. And for example, if there is a single static, it means that the correlation is significant at the point of the 0.05. This is the only difference. So now the results of correlation says that there is a relationship between all the variables. It means that our data is there's a linear relationship between the two variable over there. So the correlation has testified that there is a linear relationship among the all the variables in the data set. Now go and now another tool we are going to use, that is about the graph. Through the graph we are going to check it. How to check it? How to check it? It's very easy. Again, just we have to now this time we have to use the graph over here. How to use the graph? It's very easy. Just go into the graph and then go into the legacy graph and then come at the scattered dot graph. In this way, different five type of the graphs are there, but we are only interested in the simple scatter graph where we are going to compare or to check the relationship between the two variables. That's why define it, and then this type of window will appear. Now here QPE is our, we always keep the QPE on the y-axis because this is our dependent variable. Then we will we are keeping the food quality at x-axis. Now is there are the six independent variable are there. Now here we will check only one. Okay, the rest of the thing you can do over there. Then you can here like the food quality. Sometimes you can keep the your service quality, and sometimes you can keep the balance, and you can check all these by yourself. So just for your understanding, I'm going to do one or two. Okay, and then click OK. When you click it, then this type of the graph you will receive. This is the graph which now these like the black dots, these are our data points. Now from this one we can understand that roughly there is a linear relationship between the two data set, like between the QPE and the behavioral intention. Roughly we can understand. Now if we insert the regression line, then we can be sure how to insert the regression line over here. Just double click it. Now double click it. After this one, you see another window has been appeared before you. In this way, we have to find the regression line. Where it is? Oh, yes, here is a regression line. 8 the fit line at a total. Now click it. If you click it, another pop-up window will appear. Here different options are there. Mean of the y, linear, losses, quadratic, and cubic. Our because we are interested to check the to insert the linear line. That's why we have to check this one. Otherwise, you can do this one. You can also, but we are doing this one. Okay. Now another thing is that now this one graph, this bar why this regression equation. If you are interested, then keep this check there. But if you are not interested in this one, you want to remove this like the regression equation, then uncheck it. It will not appear. So I'm unchecking it. Then just apply. When you apply, close it. Now this line is now this is a regression line. Now you see the data points are above or below on this line. It shows that our data like the relationship between the QPE and the intention is linear. Okay, in the relation we are trying the go the same thing. Now this time we will not go through the graph, but we will go through the recent used dialog box. Current it, open it, and then the same scatter plot is available here. Just you do not do anything, just replace the behavior intention with any other of which you like. For example, I'm inserting the restaurant image. Just insert there in XSS and then press the button OK. Okay, once you press the button OK, you will get another this type of the drop. Here, this time we are checking the relationship between the QPE and the restaurant image. So the same data points are there. So now data, if you roughly understand, try the again there is the like the linear relationship between these two variables because we checked out its correlation. So the correlation value between these one, there's was a significant relationship between the QPE and restaurant image. So that's why you're seeing that there is a linear relationship between these two data points. Then now insert the regression line, the double click it. Okay, this has been, and then, okay, this is our line which we want. Select it and then linear, and we are not interested in the regression equation. Uncheck it, apply it, and then now close it. And from here you can see that our data is linear because the regression line data points are here. Now, if you remember the theoretical part of the in the PPT slides, you see that there was a curvilinear relationship, or there is also exponential or parabolic curve. So there's no any curve. So now it is the linear relationship it is there. So from this point of view, it is a linear related with each other. Okay, and if you want to change or edit some chart size, fill bordering, you can do all these things with yourself. So from this point of view, this graph shows that there is a linear relationship between the QPE and the restaurant image. Now, as you know, there are the different variables are there, so it is quite difficult to go to check the linear relationship between the all the variables due to the time. So now I'm going to check the relationship among all these one in one go. Now, earlier we checked individually the impact of the food quality, the relationship between the food quality and service quality, the relationship between the food quality, like the customer service quality. Now, this time we are going to check the relationship of all these one collectively in one go. Now, what to do? Then again go into the graph. Now, this time we will open the graph board templates chooser. Open it now. If you open it, then the same the variable are available here. Now what you do that if you press it, the different like the graphs are available, but we want to check that now collectively. Then you should choose all these one. When you choose the parallel and the scatter plots, so these two will appear. So now we want to check the scatter plot, and then just click it, select it, and press the OK. When you press the OK, now this type of the graph will appear. Now it will take time. Okay, now the graph has been appeared. That's fine. In this graph, you see that on one hand, the restaurant image, the relationship of the restaurant image with the quality, with customer service, and with the behavioral intention, with the service quality, with food quality and QP. That means here the relationship of the one variable it has been detected with the relationship of with the rest of the variable. So it is a quite comprehensive, like the graphs are there. That means all the graphs are in it at one place. So now, if you find it difficult to check it, to understand all these ones, then alternative what you can then you just press the right button of your mouse and then copy it. And once if you copy press this button, the whole process this process will be completed. When this process will be completed, then you will be able to open your Word file, and then you can you can pass these results over there, and then you can check your these results. Alternative, if you want to take their print, then the print option is also available to you, and through this one you can also check this one. Now here, if you see, that is the relationship between, if you draw a one line with your pen, like here you will see that there is a linear relationship between the valence quality valence and the restaurant image. The same you are finding the linear relationship between the customer service and the restaurant image. It's the same in all. You'll find that positive like the linear relationship between the two variables. Now the relation may be negative or a positive, but the relationship should be there, and that should be linear. So now, if you want to edit this one, you can also edit this one. Okay, now these graphs are available in the graph board editor. In this way, you can select this one, and from here you can change the secondary border or color of the selected item. So you can change the border of this here, and then okay, from here you can change the what you can say. Okay, from here, okay, change the color of selected item. You can change the color of selected item, and then what you change the here from here you can change increase or decrease the opacity, and from here you can put the different type of the like the means pictures over there or graph like this one. And this area here, the font style, this is a font size, and if you want to keep it the bold or like italic, the central alignment like this one. And from here, what you can do that okay, from this one, if you press it, then change the symbol. The color of this symbol will be changed. Now this is the circle. You can put the triangle and different type of the symbols over here. Okay, here it was all about the graph board editor, and then we are going back again, like the whatever changes you have made into the graph board editor, then same changes will appear over here. Okay, and then we are going back to our main slide. Okay, now we checked out the relationship among all these one and found that all the variables were linearly related with each other, or there will be the linearity between the among the all the variables with each other. So now this assumption has been made along with a certain assumption. Is I'm again repeating because this is the most important assumption among the all the assumptions. So that's why it's very important. So fortunately that we have made this assumption through this data. And then I hope that means you have understood through this video data how to check the linearity of the data in your SPSS. Dear friends, thank you very much for watching this video. I hope that you have enjoyed this video, and if you like this one, then please share and subscribe my channel. Thank you very much.